Isometric pictorials. The word isometric means equal measure. Three adjacent faces on a cube will share a single point. The edges converge at one point, or what we call the origin. Lines will appear at 120 degrees or 30 degrees from the horizontal line. These three edges represent height, width, and depth as seen in the red lines in the image. Isometric views can be represented in two different view orientations, as shown below. We will use the top, front, and right side view orientation shown in the bottom left exclusively in IED. Please note the orientation of the bottom left image, with the front view facing towards the left and the right view facing towards the right. Recommendations for how to select the front view of an object. First, it needs to be the most natural position or use, shows the best shape or characteristic contours, longest dimensions, fewest hidden lines, most stable or natural position. You will not be able to meet all of these recommendations, but you want to try to find the most of these as you're trying to identify the front view. You want to try to meet as many of these recommendations as possible. Here's an example. So this object, the front view is facing towards the left. The best front view is being pointed towards right here. So that is recommended to be the best front view of this object. It has the best shape. It shows no hidden lines. It's got the longest dimension. The box method is a sketching technique used to maintain proportionality. It starts with a sketcher envisioning an object contained within an imaginary box. Good sketching requires a good sense of proportion and the ability to estimate size, distance, angles, and other relationships. The following examples show steps used to create isometric sketches of simple geometric objects, including tonal shading techniques. Example 1. Lay out the box that will contain the isometric view using points and construction lines. You'll notice the red dots. Connect those red dots to create the front face or the right side face of the rectangular box. Locate the points that would locate the other edge of the front face of this rectangle or this imaginary box, and then you would do the same thing for the top of that rectangular cube. Then you would locate the features or the corners of the object, which in this case is the little sloped ramp. You would lightly draw those edges, and then you would go back and darken in the shape. In this case, there are no inside faces, so this object is now done. You can decide whether or not you would like to add tonal shading. Example 2. Determine the overall dimensions of the object. So we have this object on the screen that we're going to sketch. It's 3 units wide, 2 units tall, or 2 units deep. And when we say units, we mean little cubes. Use points and construction lines to lay out the box, the imaginary box. So they are sketching the overall imaginary box that object could rest in or sit in. Use points and construction lines to identify corners and edges of the object faces that occur on the surface of the box. So for in this case, they're locating the top of the cubes that would be in the top plane of that object, and then the front, and then the right. Before the sketch becomes too congested with construction lines, trace the visible edges, and that is very important to do when you can. When you know you have finished edges, is going to go ahead and darken them, as they do in the example. Use points and construction lines to identify the corners and edges of the object faces that occur inside the box. You could have done that in any order in this example. And then trace out the remaining visible edges. Apply tonal shading. Here's another example of an isometric sketch. Notice the use of shading and how it enhances and makes this object more realistic. Notice this one doesn't have shading and is not as realistic as the other one, but it still serves its purpose and is still acceptable. Here's another historical example of a sketch, probably for some patent.